All right. So good afternoon, everyone. Nicolas Roard. I'm going to talk about constraint layout. So if you're not in the right room, now is your last chance to leave. So supposedly, I think you, considering that it's supposed to be an advanced session on constraint layout, you should know what it is. But if you don't, it's an expressive layout manager. It's basically trying to focus on letting you do flat layouts, and I'll come back on explaining a little bit about that. It's deeply integrated in Android Studio. It's actually the same team that works on the layout editor in Android Studio and on Constraint Layout. It's an unbundled library, which is great, which means that you don't have to wait 2 years to get a new release. And it's compatible with basically every device and every system. So, quick, why do we have constraint layout? That's a typical screen that you probably did yourself in some ways. Nothing special here. It's a bunch of relative layout containing widgets, images, buttons, and whatnot, containing other relative layouts, containing linear layouts, and etc. It's not even the most horrible layout I witnessed. So I'm sure it should look familiar. So the issue with that is, if you look at it in terms of the actual nesting, the hierarchy, and what that means, you end up with something like that, or in an exploded view, something more like that. And that's not great. So I call that the Tetris model, right? Because it's relatively easy at first, right? You just have blocks and you combine them. But it can get very complex very, very quickly. So why? Because once you created your layout, even though it might have been relatively easy to do, it's very difficult to change. If your spec changed, you probably have to redo a lot of your layout. It also imposes limitation on what you can do with animation and transition, because, well, guess what? Those layouts that you are using to set up how your screen should look like also impose clipping areas and things like that. So if you want to move an element that's really done below the hierarchy and move it somewhere else, you can have some interesting issues. More interestingly, at least for me, because I was in that position, it's not a great way to, it's not a particularly helpful architecture if you want to build a design tool. So not your problem, apart that if we can make a great design tool, that's probably good for you. And finally, if you have nested hierarchies like that, performances can become an issue. It's less and less true, I have to say, simply because devices are faster and faster. That said, in many cases, you still need to at least be aware of that potential issue and remediate it. So really, if we look at that, what I would love is to get rid of all of that, okay? And basically, that's what we've been trying to do. So we move all the views on one end, all the layout information, all the rules, all your design, everything that specifies how your screen should look like. We move it into one place, and I think that's a key concept here. It's that layout should not be related to your view hierarchy. It should not be, because if you do that and you completely intertwine the layout rules with your views, well, you tangle them together, right? Which goes back to what I was saying earlier about the difficulty of changing it. So that's this idea. You can call it like flat layout if you want. This idea that as much as possible you should try to have a shallow view hierarchy. Doesn't mean that you have to have a single level of hierarchy, but as much as possible, keep it pretty shallow. So as I said, we try to non-mix the layout definition, the rules, with the view hierarchy. Makes it a lot easier to manipulate all of that into a graphical editor. Much easier to change. Animation is nicer. There's also a small point that maybe I haven't talked much about, but if you put everything at one place, it makes it a lot easier to optimize, rather than having to optimize every single layout manager. And sometimes there is some optimization you cannot do because they are just cross-cutting. But if you put everything at one place, you have a lot more opportunities. So indeed, if you take this same exact screen and you convert it in something with constraint layout, that's what you end up with. So that's definitely shallower, let's say. It also has some impact on the performances. In that example, that's running with Constraint Layout 1.0.2, which is the latest stable release that we did, running on Nexus 5X, and we are a little bit faster. There's actually going to be a blog post from DevRel about how to get those performance measures and explaining how they got those results, which in general, I'd say, it applies to way more than just constraint layout. So I think that would be a great blog post to read, maybe in a few weeks. So if we do that, if we want to have something that's really flat, that's with all those nice features, if it's flat, this is great. There is one caveat, is that suddenly it means that whatever big single layout manager we are doing needs to be excessively expressive, right? Because you need to be able, in a sense, at least on paper, what you would like is something that can reproduce all the existing layouts. So how do you do that in a single one? Well, that sounds tough, but luckily, some very bright people did a lot of work in 1947. Danzig created the Simplex method, which is basically a solver for linear programming. Think about gigantic matrices representing equations that you want to optimize. That looks like that, right? So, I remind you, we are in a UI layout talk. So, of course, you're all very familiar with this type of math. But basically, you take an equation, you have some constraint on this equation, you put that into a matrix, and magic happens. You get an optimized solution. It's actually very interesting, but let's move on. More, closer to us, in '97, Cassowary, the Cassowary algorithm was published, and it's basically a tweak on the Simplex method. In essence, it is a Simplex method, but a couple of extra features. One, it provides a method to build such a system incrementally and update it incrementally, which suddenly makes a lot of sense when you are dealing with real-time UI, things that has to react instantly when you maximize your window and things like that. And it has a bunch of things on how to more easily represent the type of problem you would have to represent for layouts. So that's a great thing. Problem with it, or advantage, but it's that yes, it's very flexible. Compared to some simpler scenario or some simpler methods, it can be relatively heavy because, again, think about what I just said. You take all those, first you have to write the right equations, then you have to put all those equations into matrices, all the associated errors, which are variables as well. So you end up with gigantic matrices. And even if you try to be careful in how you do that in your implementation, that can be pretty heavy. And if all you are doing is a very, very simple, something like a linear layout. Well, linear layout, if you think about it, if you ever were curious and looked at the code, it's pretty damn simple. So, of course, if you have to build up an entire cathedral to resolve the same problem, even if your cathedral is very optimized, might not be so fast. Yeah, corollary, if you build a cathedral, it's probably going to be pretty intensive memory-wise. And indeed, like the first implementation of Cassowary were not exactly super fast. And finally, there is also this little issue about specifying layouts with equations, which definitely is something that can be very handy. That's not automatically the most familiar way that people think about UI. So for constraint layout, we actually decided to build constraint layout on top of the Cassowary algorithm, but we implemented our own version. It's very memory efficient, in fact. I think last time I measured it was like 80 kilobytes per thousands of constraints, so you should be all right. More importantly for us, it needed to have good performances on both Dalvik and Art, which had some interesting side effects. Incidentally, on Art, it's really fast. One big difference that we did, and I think that's really one of the key stuff with constraint layout compared to other approaches or similar approaches, We did not simply say, well, you know what, we got this amazing solver that can solve everything you throw at it, and yeah, no, go do equations. Instead, we specified a much more simple constraints model that basically sits on top of that solver. So fundamentally, you got, if there is only two things you try to remember from this talk, is that you have, and you don't know much constraint layout. Constraint layout lets you do relative positioning, position an element relative to another one, and it also lets you center that element relative to two endpoints, right? So there's a concept of targets and anchors, but fundamentally, that's what it does. I saw it referenced as, constraint layout is kind of like if linear layout and relative layout had a child. It's not quite true, but there is a little bit of truth in it. The other thing is that we do not expose any of those equations to you, but I have to say it is evolving. We are adding new things as we go along, but we are trying to balance the power versus the complexity. So just to recap, that's what I mean by those relative positioning, right? I have my second button is being positioned relative to that first one. So if I move the first one, everything moves together. And the second one is the centering. So here the button is basically connected to those two ends and is centered by default. The really cool thing is that you can actually apply a bias. So it doesn't have to be I'm centered at 50%. You could be, well, I am centered, but at 75%. So that makes, that allows you to build UI in a much more flexible way. And that's it. Talk is done. Constraint layout. Now, we are doing a little more things. One thing we are doing that I think you should be aware of, even though that's very much an internal thing, it's, okay, we got this solver, and we got this constraint model, but really, one of the nice things is that we have an optimizer that sits in between those two layers. And that actually is where we got a lot of the performances that we lost to the solver, because in many situations, we can actually do a direct resolution. So in that case, we are doing what linear layout does in cases where we can, basically. So let me go through the optimizer a little bit. Fundamentally, anything that is not ambiguous, that is pretty straightforward, well, let's just resolve it directly, right? We don't have to run the solver. One thing you may not be aware of, there is an actual XML attribute. We haven't talked much about it, but you can specify the level of optimization. So we are actually, refining a lot of the solver in the upcoming the next version of 1.1. If you end up having some issues, maybe try it without the optimizer. But fundamentally, that's more for us. But if you want to test things, that's kind of nice. And the optimizer has multiple steps. We are doing something for wrap content, we're doing something for the direct resolution, something else for chain as well. So and one thing that's very important, match constraint, in general, that's pretty costly. That's the equivalent in linear layout if you use 0DP with weight and stuff like that. That's kind of what match constraint is. And why is it costly? Because actually, most of the time in your layout, what ends up being expensive is not so much the layout, it is the measurement of your widgets. Particularly with text, it can be very, very expensive. Of course, the Android framework does a bunch of things to try to cache those results, those whatever values they come up with when you do wrap content. But with match constraint, what we have to do is to do two measures. Again, that's basically what linear layout does as well in the same situation for the same reason, essentially. But basically, if you're using match constraint, be aware that that particular widget will have to be remeasured a second time, because we first measure it in its minimum size so that we can kind of bootstrap the system. And then we measure it a second time with the final dimension. So if you have a custom widget that is very expensive in its measurement, be aware of that. It's not fully true. There is some situations where we don't do that. In some cases, we don't care about the original dimension, so in that case, we don't even bother measuring the first time. But fundamentally, if you can keep everything as fixed dimension, and I include the wrap content in that case, it's probably the fastest, right? So if you have just a bunch of buttons with wrap contents, that's super, super fast. The other one is not super slow either, but just to give you like a little bit of feel on the cost of the different operations. One thing we are doing a bit different is if constraint layout itself is set as wrap content. So if it tries to basically calculate its minimum size depending on the widget it contains. In that case, we are trying as much as possible to not run the solver as well whenever we can. So if you don't have ratio being specified on your element, if you are not using %, because of course if you're using % as a percentage of the container, and we don't know the size of the container, that's a little bit tricky, which is why we have a solver. But that's also why, in that case, you'll escape the path of the optimizer. Whenever we can, we try to simply, as I was explaining, just directly resolve things, right? So it's only in the case where you, in a sense, you have a chain is the correct word, but like a series of widgets that are linked together, you can imagine. And if those ones have fixed dimensions, there's no need to run a very expensive solver. You just say, well, okay, you are at this position, and oh, I know you are following it, so you are this other position. And basically, one nice thing is that as much as possible, we'll resolve those things. So in fact, it's not quite true when I say, oh, you escape the optimizer. You'll escape the optimizer for the widget that we can't find, we can't directly resolve. But all the other ones that we can, we'll resolve them. So even if you have some ratio and whatever in your layout, we'll still do some optimization. And finally, for chains, chains are a bit trickier. But if we have stable endpoints, basically if the chain is connected to the parent on both ends, and remember, like a chain is this series of widgets that are connected to each other with bidirectional constraints. And very important, the chain has to be connected on both ends, on both terminals. At the end of the chain, it has to be connected on one way and the other way. So if those ends are stable, meaning that it's the parent, and the parent is not in wrap content, or it's a guideline, not a percentage guideline for the same reason, unless the parent is fixed as well. In those cases, then we can optimize. But otherwise, we'll have to say, well, let the solver derive it. And right now, there is more than a couple of situations where we don't even do optimization, and that's something we'll clearly want to improve. Let's quickly go back on the functionalities of constraint layouts. By the way, in this room, how many people actually use constraint layout? Okay, so you're pretty, let's say 50% of the room seems to be pretty comfortable with it, hopefully. Good. So I'll go relatively quickly. In the 1.0, which is the current stable, what constraint layout provides you? Relative positioning, the center positioning and bias that we just saw. It also has this concept of helper object, because it's great to say, oh, you want your hierarchy to be flat and etc. But clearly, at some point, having nested hierarchy also helps you create your layout. It could be used not as because simply you need that in order to get the result you want, but more as well, I want to organize my screen in multiple sections. So along those lines, we have this idea of having helpers objects. So those objects are actually at the top level as well, but they don't really participate into the view hierarchy, but they do participate into helping you create your layout. And guidelines is the most famous one. And basically that you can think about like those vertical or horizontal lines that your designer lovingly give you, and you can now basically recreate a screen much more easily if that's what you get as a spec, because you just have to recreate those guidelines and that's it. And you simply put your elements relative to those guidelines. You got the chains. Again, that's like this. It's kind of like a way of taking a series of widgets and applying to them a kind of group behavior. So you can, in essence, you can do what linear layout does with a chain, but one big difference, it only works in one dimension, meaning that you can actually apply a chain in, let's say, in horizontal, and in vertical have completely different behaviors. While with linear layout, it would be one or the other, and the other axis would be also constrained by linear layout. The other thing is that we actually do more than linear layout. We have a couple of extra behaviors that are interesting that would be a bit more annoying to do with linear layout. And that's kind of what I'm saying, like where we are going to enrich constraint layout, the library, as we go along, adding more helpers, more concepts that would help. One thing we added as well was the ability of setting dimensional constraints. I'll cover that a little bit more. But basically think about ratio. And finally, constraint set. And I'll talk more about constraint set as well. I think that's one of the really, really nice features of constraint layout. Another feature that I don't know if you're aware of, it's the gun behavior. If you ever played with relative layout and gun, you might have had some surprises. The behavior in constraint layout when you have an element that's marked as gone is very clear. The element becomes equivalent to a point with a dimension of 0, 0. And whatever relative position it had, with possibly a gap, a margin, those margins get resolved to 0 as well. So that's what you see here. So that button in the middle is marked as gone, and everything just collapses in a nice way. So that's great. Problem is that if you do that on the first element, using the same rules I just described, that's probably not what you want to get, right? So we have an extra concept, which is, well, if you are connected to a target who happens to be gone, in that case, use that value for the margin versus the normal value. So in that way, that second button can take care of the fact that the first button is marked as gone, and everything ends up where you want it to be. So gone is very interesting because that kind of allows you to tweak your UI in a very flexible way without having to redo an entire layout. So think about it. It's a very, it's a nice trick. Here's a small example of the type of things you could actually build pretty easily with just marking those elements as gone and the rest of the constraint collapsing correctly. The animation is done by the transition manager. It's not constraint layout. It's everything you did in layout, you can animate. Thanks to Chet. All right. So 1.1 beta 1 is something we announced at I/O. Summer has not been too kind on us. We haven't released a beta 2, but it's coming. What did we add? We added barriers. And barriers, for me, that was the last big concept that I think we needed in order to be able to replicate all the type of UI we are interested in. And that's basically that. So not sure if you can see very well with the animation, but you can see that if I move that button, everything moves up to the maximum of those two buttons, right? The checkbox and the button. So the button and the checkbox are part of the same barrier, and that's why you see this vertical line on their right. And basically the barrier is simply saying, in that case, well, take the maximum of the side that I'm constrained to. So if the button is the one that's at a higher value, the guideline will be constrained to that. If it's the checkbox, same thing. Here's a couple of other examples to make it a little clearer. So you may have had a similar problem. You have a bunch of text items, of labels, and you want to put an element on the right of whoever is the biggest. And you can do that by encapsulating those into a linear layout. But again, with the fun if we have to use linear layout. So what you can do instead is you create a barrier, and the barrier will contain those three elements. And then you can have this validate button being simply on the horizontal axis, it's constrained to the barrier. So if those elements increase in size, whoever is the biggest will be the one controlling the dimension, the distance of the barrier to the side. But there's an extra twist here. If you notice, all the three elements are also constrained to the barrier and to the left side, which allows them to be centered, of whatever the barrier is to the side. So you can do a bunch of clever combinations like that. And what's nice is, you see, like if the title changes, everything just recompute correctly. And that's how it looks in XML. So you basically have these constraint reference IDs containing just the IDs of the elements you're interested in. And you can specify a barrier direction that can be left, right, top, bottom, start, or end. And that allows you to control where the barrier can be. One nice thing, it's not a view group, right? This is just referencing those elements, meaning you can have more than one barrier referencing the same element. So another thing we added was group. And you'll see it will have some similarities with barrier in some ways, but group, the idea is that, well, I just want to apply visibility to a set of widgets. And that's something, of course, you can do by hand, just in your code. But what that means is that you have to maintain your own list of widgets. It's just annoying. So if we could specify it in XML, that's probably better. And this is exactly what group are for. So if I take that same example, that the text view 2 corresponds to this element, text view 3 to this element, and let's say that they belong to the same group. And like that, so I just put text view 2, text view 3 in the reference IDs, and that's it. And you notice the Android column visibility. Groups for now are very poor in terms of what they can do. The only thing they can do for now is setting the visibility. But if you set the visibility on a group, it will apply the same visibility attributes on the element it references. So that's what you'll get if you mark them as being invisible. More interestingly, that's what you'll get if you mark them as gone. And then everything just collapses as we just saw before. So that's a nice way of grouping the type of management that you would have to do otherwise. Just put them into your XML. It's probably easier. And of course, in Android 3.0, Android Studio 3.0, it's supported in Layout Editor. So you'll have the component tree showing you all your elements. And you'll see that for the groups, they will look in the component tree like if they are a view group. They will contain those different references, and you can reorder them, delete them. If you drag an element onto a group or a barrier, it's the same behavior. They will be added and stuff like that. So again, if you are not using the Android Studio Layout Editor, take a look. It's trying to help you. Another thing we added was placeholders. So that's a little more, I think the jury is still out on this one. If it's that useful or not, it can let you do really interesting stuff. So a placeholder is basically just, it's a widget that doesn't do anything apart from the fact that you can set up the whole constraint system onto that widget as well. Why would you do that? Well, because then you can, if you call set content ID, you can replace the content of that placeholder by whatever other widget you have on screen. So in that example that you see on the right, we have a placeholder that put itself on the top left, and we have a bunch of buttons that belong to a chain that are on the bottom row. And by setting the content ID of whoever I just clicked on, it will replace the content of the placeholder with that button. So that just means that we can move an element to wherever the placeholder is. That's one way of using placeholder. Another way is to use it kind of template mechanism. But that's one usage I'm not entirely sold on. But you can imagine basically using placeholder the similar way. So you could prepare an XML file with the right placeholders, and when you could then from a different XML file just merge that file, putting the right IDs for whatever element you have, and everything will be put correctly. So really, it's kind of like a template system. Finally, one of the last thing we added in beta 1 is person dimensions. And person dimensions belong to the class of dimension constraint. Told you I was going to talk about it. So a dimension constraint, it's a typical thing, right? That's what when you set layout width, layout height, and you set, in other layouts, match parent, you set wrap content, or you set an actual dimension. One thing we have with constraint layout is this concept of 0dp. Again, this is the same way that that linear layout specified a similar behavior, so that's what we use 0dp to say that. We call it internally, or in the documentation, match constraint. And really the idea with match constraint is that the dimension of that widget that's set to match constraint will match whatever constraint you have, minus margins. So the default behavior is to spread. Right? So if you have an element connected to your parent on both ends, and you mark it to 0dp, you will see your element just grow and take the entire width of your parent. But now we can actually specify different type of behaviors. We can specify spread, that's the default. We can specify wrap, and basically wrap behaves like wrap content. And you can specify percent. So one difference with wrap content and using 0dp and wrap is that if you are not too constrained, it will behave the same. Meaning if you have enough space, it will behave the same. But if your widget does not have enough space with wrap content, because we consider internally as just a fixed dimension, it can actually go beyond the bounds of your container. If you specify match constraint and wrap, it won't, we will actually apply the constraint. So another way to think about that is if you want to do something like that, right? If you have some text that can grow, but up to a certain size, and after that maybe ellipsized. So if you want to do that, it can get tricky. But with the marking it as match constraint, you can do that. So if we go back to the simpler example of I'm having a button connected to my parents, if the button is smaller than the space you have, the button will be centered by default. That's a centered connection. If you mark it at 0dp, it will spread out. If you mark it at 0dp and change the default to be wrap, it will basically behave again like a wrap content button. Where it gets interesting is that if that button or that text view, if the content expands it, it will be limited by those same constraints. So the reason because frankly, we could have done exactly that if you are just using wrap content, after all. But as I said, if you are using wrap content in this way, you will have to do another remeasure and stuff like that. So we kind of prefer to keep it very clear. If you are using 0dp, you know that maybe it will be another extra pass of measure on that element. When I talk about a second pass, it's only on the element, by the way. It's not like we have to redo the entire stuff. So we preferred it to be very clear. So wrap content and fixed dimensions, cheap. Anything else can be more costly depending on the circumstances. But that's one way where you can have something that will be limited to whatever constraint you have. And of course, in that example, I'm talking about the parent, but it's any kind of constraints you have. So in that previous example where I was showing the text being growing up to a certain limitation, this is what we actually have. We have a chain of 2 elements, and the element in red is marked as wrap. And this is exactly what you'll have. The only difference here I didn't indicate, and that you saw in the screenshot before, everything was set up on the left side. How do you get that? Easy. It's a chain, but you can mark everything to be biased toward the left by setting it at bias 0. So just to give you an idea that, yeah, there's all those different concepts, but those things can and are meant to be working together. So you can actually generate very complex behavior. But we are trying to keep the tool set pretty small. So another thing we added was person dimension. Again, that's part of this dimensional constraint stuff. So you have to mark it as 0dp, match constraint. And you have to change the default to be, well, %. That's actually another reason why we did it that way, is because it allows us to more easily define multiple versions of whatever we want the behavior to be. And so if you set it as being %, you have to specify a width % attribute, and that will just get the percentage. By default, the percentage is based on the size of the parent in that dimension. But we are thinking about extending that and having a percentage-based size that would be maybe getting from a different widget instead. Importantly, for 1.1 beta 1, that's the first time that we've been releasing the library on Maven. So now it should be really easy for you if you want to test it and get it with your, your test servers and whatnot. Just open your Gradle file and add those lines, and you're good to go. I'm going to talk a bit quickly about constraint sets. So the idea of constraint set is, as I said, if you remember that, views, layout, two different things, or should be. What we have is this concept of constraint set, where, in fact, the constraints themselves can be represented as a single object, a single concept. And you can replace them, right? So you keep everything the same, just replace the constraint. And that's very powerful, because that means that you don't have to reinflate everything, to recreate your object, your views, and etc. So we encapsulate all those constraints into one object. How do you do that? It's pretty easy. In code, you create your constraints. You can get your constraint set from an existing file or from an existing view hierarchy at runtime. And then you just call apply to on the constraint layout container that you want them to apply on. And that's it. So you could do stuff like, well, I want to deal with landscape, but without having to recreate my view hierarchy, create two constraint sets. And then when you rotate, nothing is reloaded. It's also very useful for motion, right? Because for motion in constraint layout, you can think about motion as, again, we are trying to get a flat hierarchy, not having any clipping issues. You can think about the constraint layout a bit like a scene graph, right? Just now we have separated the layout from the views, and we just have the views. So what we have is just a graph of views we want to display. And you can think about constraint set a little bit like a keyframe. So go back to that same example, and we just add this line, and suddenly you can do things like that, And this is simply done with having two different constraint sets, having those objects that are hidden by default and showing up again are just hidden by default. So what's kind of nice is that you can build that really easily in Studio. Just build two different versions of your layout, and that's it. So it's a very visual way of creating this type of animation and transition. You can also think about constraint layout as a bit as a choreographer for that scene graph, right? Because we've been playing with widgets so far, buttons, labels, and whatnot. But nothing prevents you to actually use other components. Could be fragments, could be other constraint layouts, your custom views, whatever. Here's a short example. That's reusing the nav view, but that's not reusing the drawer layout. It's just using a constraint layout subclass that override like the swipe motion, and you just move it like that. And basically, you can use constraint layout as I said, a choreographer. What's cool is, because it's a slightly more higher level to express this type of motion and animation, you don't even have to use navigation view. You can just roll up your own, And that's what I'm more excited about with constraint layout, like the next versions, is that we can express things at a higher level, and therefore I think we can give the developers the opportunity of really going in a very flexible way about UI, rather than thinking about, I just have the set of components that Android is giving me. Quick last example about animation. Similar stuff. You have two different constraint sets, you animate. It's very lame. you could do more interesting things because the Transition Manager framework allows you to create your own transition. So here, this is just a preposterous example using physics. Don't do that in your UI, but just to show you that, yes, you can override things and you can have interesting behavior. All right, what's next? Well, basically, we are still working on performance optimizations. Right now, I think 1.0 is in a pretty good shape. 1.1 is actually a little slower right now, but we are setting up the pieces to actually be faster. One of the things we experimented with, for instance, was doing the resolution of all those constraints in background threads. Also segmenting the constraints that are related. You can actually cluster them. And in general, we can do a lot more with the optimizer. So actually, that's my time to say, if you have examples of UI that are slow in constraint layout, don't be shy, send it to us, and we'll improve that. Another thing that we're working on is, if you notice, both groups and barriers looked pretty similar in the way they were architectured, at least in the XML. And that's because they are both deriving from Constraint Helper, which is an internal class. But actually, it's a public class, so you'll be able to create your own constraint helpers if you want. A couple of constraint helpers that we want to put out. We want to create a constraint helper that very trivially create a chain. And now you should shout at me and say, oh, you are recreating linear layout. Kinda. With the caveat that, again, you can have, like those helpers can reference the same element multiple times, right? And more importantly, we have the control on what we can push in the library, and we can add more features and do more stuff like that. Layers is an interesting one as well. Think about groups, but visually. So with layers, what we are thinking of in terms of features is, for instance, well, maybe I want a background on whatever is the bounding box of the elements that are contained inside me. Or that could be, apply a translation using the barycenter of myself on everyone. So it's super easy to move things around. And so there is interesting things like that we are thinking of. Finally, we want to do a lot. We are very interested into motion in general, and I think we have a couple of ideas to help you with creating motion in your application. Documentation. So we as Google, we put up an interesting documentation, but the community has been absolutely phenomenal. There is a website called ConstraintLayout.com that actually references a bunch of articles. So if you haven't looked at Constraint Layout, you can take a screenshot of that, look at it. YouTube has a ton of video as well. Yeah, and don't hesitate to contact us on Twitter or Google+. We are pretty responsive. And that's it. Thank you.